flip flop is considered as a D flip flop. It name suggests that is delay flip flop. So most of the time it is asked in your Viva questions. So what is the long form of D? So D is considered for the delay. So why it is a delay flip flop? So because the Q output here, if you consider the Q output, always take on the state of the D input at the moment of rising clock age. It means that when the clock pulse is applied, whatever the input is there, okay, same input is given as the output. In that case, we can say that the output is same as the input. So if D is equal to 1, then Q is equal to 1. If D is equal to 0, then Q is equal to 0. So we can say that output is equal to input. But when the output is equal to input, when you are applying the clock pulse, when you are applying the clock pulse, then and then you are getting the same thing, that is output is equal to input. So in most of the registers we are using the such kind of D flip flop, because the register, some of the registers are used for the temporary storage purpose. So for that purpose they require the output is equal to input. So in that case, the D flip flop can be considered. So the output takes the value of D input or the data input and delay it by one clock count. That's why it is called as when the output is equal to input when clock pulse is applied. So the delay in between output is equal to input is nothing but the one clock pulse. So that's why it is called as a delay flip flop. So the truth table, if we are considering the truth table, so here this is the circuit SR flip flop you can consider, okay, or the JK flip flop you can consider. So here if you are considering the J and here K, so there is a NOT gate is required, because for D flip flop we require only one input. So in that case, when if you are considering this is a JK flip flop circuit, so here J is equal to D and K is equal to D bar. So here in this particular flip-flop, we require the only one input, that is D. So the value of D input either 0 or 1. Now Q n plus 1, this is a Q n plus 1, that is next step. So it is equivalent to D. So if it is D is equal to 0, then Q n plus 1 is 0. If it is equal to 1, then Q n plus 1 is equal to 1. So that is nothing but a delay flip-flop. It is a simplest flip-flop. Then the last flip flop is considered as the T flip flop. T indicates the toggle. So when the in which flip flop the toggle condition is occurred, if you observe in JK flip flop the toggle condition is occurred when the JK toggle condition occur when JK value is equal to 1. In that case, toggle condition is occurred. So we are considering this JK flip flop for designing the T flip flop, and the same inputs we are considering, because when if J is equal to K, then the resulting flip flop is referred to as a T type of flip flop. So here it is considered as a T, both same input is applied. In previous case D flip flop, here we require the one NOT gate, but here we don't require the NOT gate. Same input is considered for J and K. Now if it is toggle, so when the toggle condition is occur when J and K is equal to 1. So here if you observe Q is equal to T is equal to 0, then in that case Q n plus 1 is depends on the previous state, that is Q state. Okay. But when T is equal to 1, so J is equal to 1 and K is equal to here. If T is equal to 0, then J is equal to 0 and K is equal to 0. If J is equal to 0 and K is equal to 0, then what is the output? Output is previous state, or there is no change in the output. Okay, so it is considered as a Qn. See here in truth table, you can consider this is Qn plus 1 and this is Qn. Okay, then when T is equal to 1, then J is equal to 1 and K is equal to 1. According to the JK truth table, it is a toggle condition. Toggle condition can be represented by this Q bar. So here it is considered as a Q bar. So this is